So last time we did enthalpy of solution, and enthalpy of solution was that 1 mole of a substance dissolving to form aqueous ions, especially for ionic compounds. Okay. So you've got 1 mole of substance, and eventually what will happen is that the ions will dissociate in water, and water will what will water do? Water will it's going to surround the ions. It's going to be attracted to the ions. Okay, especially the negative part of water, which is the oxygen having lone pairs, that's going to get attracted to the positive ion, or vice versa. The negative ion, if you have a negative ion, so the positive part of water molecules is going to get attracted to the negative ion. So positive part कौन सा होता है? That's the H positive. ठीक है. So the H positive part of the water molecule is going to get attracted to the negative ion. Anyways, in both cases, the positive or the negative ions are going to get completely surrounded by water molecules. And that's what dissociation is. Okay, you've got an ionic solid, you put it in water, you stir it, the ions dissociate, and they get surrounded by water molecules. So the energy that is going to be released or absorbed, that energy is going to be that energy is going to be known as your enthalpy of solution. And there are two steps to it. The two steps are that you first have to break the lattice. So that is the opposite of lattice energy. You're breaking the lattice. So it's an endothermic process. Energy is required to break the ionic bonds. And once those ionic bonds are broken, there is enthalpy change of hydration, which is, okay, the ions are going to get surrounded by water molecules. They're going to form bonds. So bond formation is going to happen. And that part is exothermic. Okay? So you've got an endothermic part, you break the lattice, and then you form bonds with water molecules. And that's your exothermic part. Okay? So your enthalpy of solution, one path is equal to the other path. So it's equal to your negative of lattice energy plus the enthalpy of hydration. So yesterday we had to, based on this Hess cycle, we had to justify, we stated two things, that enthalpy of solution of ionic compounds, and remember, this is only for ionic. We're only talking about ionic compounds here. Okay. So you break the lattice and then you hydrate the gaseous ions. So two parts. One part is endo, the other part is exo. And I told you that if enthalpy of solution comes out to be it's more exothermic, that means the substance is very soluble, especially at lower temperatures. And if your enthalpy of solution becomes more endothermic or is endothermic, that would indicate that a lot of energy is required, and it's not going to be soluble. It's going to be soluble. It's going to dissolve at a much higher temperature. Why would enthalpy of solution come out to be endothermic? So if the lattice is very strong, so that means a lot of energy would be required to break the lattice. So if the endothermic part is bigger and the lattice is strong, then it's less likely to dissolve. The whole process will be more endothermic. Vice versa, if the lattice is very weak, that means less energy is required. And the bonds that the ions are forming with water molecules, those are strong. So more energy gets released. Then the overall process is going to be exothermic. Okay? So in that case, a lot of energy is going to get released. And that substance is going to be, it's going to be easier to dissolve that substance. Okay? Ye part clear? Is this clear to everyone? Jody, Zaina, is this clear? Baki ko Ibrahim,
Yes, sir.
Meher, right? So what we're going to do now is, okay, we're going to justify and we're going to explain using this Hess cycle. We're going to explain why this solubility. Now, this is a 4-mark question. Normally, it's a 4-mark question. It could be a 3 or 2-mark question as well, but normally it's a 4-mark question. And they're going to ask you explain why the solubility of group 2 sulfates decreases down the curve. So what's the answer to that? MgSO4 is like very soluble. Calcium sulfate is, if you already know this, it's partially soluble. And the last two, these are like insoluble. They're not very soluble. So these two are insoluble. So I'm gonna construct a similar sort of Hess cycle. So MgSO4 dissolving, So it's MgSO4 solid. And it dissolves, it turns into aqueous ions. Okay, so very quickly it's going to dissociate and it's going to form Mg2 plus aqueous and it's going to form what? SO4 2 minus aqueous. Now that's your overall enthalpy change of solution. And there'd be two steps. One is you're going to break the lattice. So you break the lattice and it turns into gaseous ions. That's negative of lattice energy or the opposite of lattice energy. So it forms ions, gaseous. And then you mix them in water and they end up forming aqueous ions. Okay, so this is your enthalpy change of hydration. And the first part is endothermic, you're breaking the lattice, and the next part is exothermic because you're forming bonds with water molecules. So we need to explain what happens down the group. Why does the solubility decrease down the group? Okay, that is what we need to justify why the solubility, okay, it decreases down the group. So the way you're going to describe this is what's happening down the group. The first thing is when you move down the group, the cationic radius increases. Increases. Like if I draw the same cycle for barium, okay, let me just copy this and I'm just going to change this to so I'm just going to change this to barium. Okay, so I'm going to just rub off magnesium and make it. Now BaSO4 is not going to be very soluble, so this is what Ba2 plus. Or यहाँ पे क्या that's also Ba2 plus. Achha, so I have this thing. MgSO4 is soluble. So that indicates that MgSO4 is the enthalpy of solution is going to be exothermic, or it's going to be more exothermic. It's going to easily dissolve. While the enthalpy of solution, barium sulfate is not dissolving. So probably it's going to be more endothermic or towards the endothermic side. Maybe the lattice is very hard to break, which is why it's kind of hard to dissolve. So down the group, what happens? Cationic radius increases. So because of that, क्या होता है? Both lattice energy, both your lattice energy and your enthalpy of hydration would decrease. Why do they decrease? Because I've told you that bigger ions, they form weaker bonds. The bigger the ion, the distance between the ions is going to increase and there's going to be less attraction. Bigger ions are going to be more shielded as well. The charge density is going to be lesser. Bigger ions, they have lesser charge density. So that would lead to less attraction. Clear, Anna? Is this clear that bigger ions always have less attraction because they've got lower charge density? Is that clear?
Yes, sir.
Okay. So both of them are decreasing. So that means okay, if I write this over here, so your lattice energy decreases. And at the same time, your enthalpy of hydration also decreases. For barium, it's going to be weaker bonds are going to be broken and weaker bonds are going to be formed. Bigger ions are not going to form very strong bonds, so the lattice is not going to be that strong. It would be easy to break. And bigger ions, they will not attract water that much. So the bonds that are going to be formed are not going to be very strong. So even that part would be less. Okay? So both of these values would decrease. But since your enthalpy of solution is becoming more endothermic, which means that since both of these values are decreasing, the lattice energy decreases as well the enthalpy of hydration decreases. Like in down the group, it's becoming more insoluble. So that means it's becoming more endothermic. So that kind of indicates that the endo part is decreasing less and your exo part is decreasing more in quantity. That your endothermic part is still bigger in size. It's harder to break the lattice, while your exothermic part decreases more, which is why it's becoming overall, it's becoming more endothermic. Is that clear? Do you get this idea?
Yes, sir.
Yes, sir.
बाकियों को clear? Is this clear to everyone? Jodi, is this clear? Zaira, is this okay? So just remember, down the group bigger ions. So both lattice energy and enthalpy of hydration, they're both going to decrease. Barium is not going to form very strong bonds. So both of them would decrease. But since your enthalpy solution is becoming less soluble, it's becoming more endothermic. That indicates that your endothermic part is still bigger in size compared to this one. So this decreases less compared to this. So the next statement in your answer should be that, but delta HLE decreases less compared to, इसको नीचे कर लें, अच्छा, compared to the other one, which is delta H hydration, the exothermic part, that decreases more. And hence, overall, what happens overall, delta H solution becomes more endothermic down the group. Or you can also write less exothermic down the group. So it's becoming less exothermic down the group. And that's it. So this is your answer. That's your 4-mark answer for this question. Which, and you always have to, I mean, you're going to get exactly the same type of question over and over again. Why does the solubility of group 2 sulfates decreases down the group? So moving on, there's another one which is explained why the solubility of group 2 hydroxides increases down the group. That's going to be a very similar answer. So question ye कि explain. So explain why solubility of group 2 group 2 hydroxides increases. Down the group. And this one is going to have a very similar answer. So the cycle is going to be the same. The first one, magnesium hydroxide, is not very soluble. It's actually not soluble at all, or very slightly soluble. Its pH होता है, that's around 7 to, it's between 7 and 8. Like it dissolves, but very, very little. Calcium hydroxide is going to be, it's going to be partially soluble. So the first one is insoluble. The next one is going to be partially soluble, and then you've got strontium hydroxide, which is going to be more soluble, and barium hydroxide. These two are going to be very soluble. These two are. And I'm going to write down their pH as well. The first one will probably have a pH of 8. And these would be like very strongly basic. It's going to have a pH of 13. They're going to produce a lot of OH ions. Calcium hydroxide would be somewhere around around 10 to 12. Okay, so anyways, the last three are like very basic. The first one is it's not going to dissolve, so it's not very basic. I said everything else remains the same. Like if I have magnesium hydroxide and I draw the cycle very quickly, so it's going to be you got a solid and it turns into aqueous ions. So it will form Mg2 plus aqueous. And क्या होगा OH minus 1 aqueous, 2 OH minus 1 aqueous ions. That's your enthalpy of solution. This time the enthalpy of solution is going to become more exothermic down the group. So it's going to dissolve. And when it dissolves, it's going to form gaseous ions. And it's going to form 2 OH minus 1 gaseous ions. And then you're going to hydrate those ions. So this is your enthalpy change of hydration. And that's your breaking the lattice or the opposite of lattice energy. So we're going to write a similar answer, which is that the first part is going to be exactly the same, which is that what happens down the group, that down the group, the ionic radius increases. So both of these values, the enthalpy of hydration and your lattice energy, they're both going to decrease. Bigger ions are going to form weaker bonds. So down the group, the ionic radius increases, or the cationic radius increases specifically. The anion remains the same. So both your lattice energy and your delta H hydration, both of them, they both decrease. One part is endo and the other part is exo, and they're both decreasing. But since it's becoming more soluble, so that means the exothermic part is relatively bigger compared to the endo. So this decreases less. So your enthalpy of hydration decreases less. Compared to what? Compared to the other one, which is your delta H lattice energy. Hence, that's why your delta H solution, your overall enthalpy change, so that becomes more exothermic down the group, or less endothermic down the group, which is the same thing. Okay, is this clear?
Yes, sir.
Yes, sir.
Okay, so ye do na, these two things, you just have to remember this because you're going to be asked questions which will just ask you to state this. Achha, so we're kind of done, TK. So we're going to start with past paper questions and past paper practice. TK, I'm going to send you the worksheet later on. Like abhi filhal we have just 1 second. Where's the Achha, now just that's this one. So I'm gonna send this workbook. So we're gonna try and do questions. TK, and I'm gonna focus on questions which would be related to the things that we just studied right now. TK, so we're gonna start with, I think, the first question. That's about enthalpy of solution, I think. So we're gonna start with this question. And starting with the first question, he says that use Ag2SO4 as an example to complete the following Hess law energy cycle related to enthalpy of lattice enthalpy, solution, and hydration. Okay, so you have to complete that. So remember, I told you that if you dissolve a substance, so what happens? It will become I mean, I'm going to go with enthalpy of solution first, okay? So it's going to dissociate into its ions, right? So it's going to form what? Ag plus 1 aqueous
SO4 2 minus.
or SO4 2 minus aqueous, right? And it's going to be 2 Ag plus 1. So what is the name given to this?
And that which is solution.
Okay, this is delta H solution. Achha, phir what is this arrow? What is this arrow then? Or maybe this arrow. I mean, what's the other path? You break the lattice, right? So if you break the lattice, it's going to form gaseous ions, 2 Ag plus 1, and it's going to form SO4 2 minus gaseous ions. Okay, so we were supposed to go in this direction, but the arrow is in the other direction. So I think he's talking about. I'm not going to write minus lattice energy. Okay, I'm just going to write plus lattice energy. Okay, because the arrow is pointing in the right direction. And then those gaseous ions will turn into aqueous ions. And that's going to be, kya hoga? This is going to be enthalpy change of hydration. Okay, is this clear?
Yes, sir.
So that's it. So second, include the relevant species in the two boxes. So we did that. Label each enthalpy change with its appropriate symbol. Complete the remaining two arrows. So this ye direction. We didn't write this direction. The arrow was in this direction. Okay, so that's the first part. That's the next one. So next one is, okay, I'm just going to focus on the questions which, this one. What is meant by the standard enthalpy change of hydration? So, okay, it's gaseous ions turning into aqueous ions, right? So it's the energy that's going to be released. It's always exothermic. When what happens? When gaseous ions, 1 mole of gaseous ions, are completely surrounded by water molecules. To form 1 mole of aqueous ions. So to form 1 mole of aqueous ions measured under standard conditions. You can try and fit that in. Because they had used the word standard. So measured under standard conditions. So next is you've used the following data to calculate the lattice energy of calcium nitrate. You may find it helpful to construct an energy cycle. So it's exactly the same thing. It's hydration or enthalpy of solution is given. So what is enthalpy of solution? You try and calculate this one. Calcium nitrate solid, right? It dissolves. That's enthalpy of solution. So it's going to form what? Calcium 2 plus aqueous. And it's going to form what? Nitrate aqueous. So that's going to be 2 NO3 minus 1 aqueous. Okay. So that's enthalpy of solution. This value is minus 19 kilojoules. Okay, that's minus 19. Now I'm going to figure out the other path, which is you break the lattice. So it's going to turn into calcium ions gaseous and 2 nitrate ions gaseous ions. That's negative of lattice energy. And then you've got this path, which is where you're hydrating them. Now you have to be careful. You're hydrating 1 calcium ion, so that's minus 1650. And you're hydrating 2 nitrate ions. So wo kya value hai? That's minus 314, right? But that's going to be times 2. And the rest is one path is equal to the other path. So that's one path. That's your other path. So that means you just have to solve this. Okay, it's minus 19 is equal to minus lattice energy. And it's equal to minus 1650. And it's equal to minus 314 times 2. Okay. So can anyone tell me what is lattice energy in this case? What do we get?
Minus 2259.
Minus 2259.
59.
This one, right?
Yes.
So minus 2259 kilojoules per mole, right? So you're getting that. So enthalpy solution, we were able to figure out enthalpy change of solution. सारों का यही है कि नहीं आया? Ibrahim, Minail, Jody, what are you getting?
तो मेरा डिफरेंट आ रहा है, मैं उसको रीचेक कर लेती हूँ.
हाँ, double check this, ठीक है? Because Zaina, did you try this one?
Not yet. I can't find my calculator.
Zuhair? Anyone, just double check.
Minus 2259. Yeah.
ठीक है, perfect. That's minus 2259. ठीक है, just remember always double check these values क्योंकि enthalpy change, the number one source of error is your calculator, ठीक है? That's where you make more mistakes rather than over here. Achha, so we found the answer. We found the enthalpy of solution. Just note this down, ठीक है? I'm going to rub this off. So minus 22. So this is minus 2259. Now, he says that the enthalpy change of hydration of barium ions, next part, is minus 1305. Suggests an explanation for why the enthalpy of hydration for barium ions is less exothermic. So that's about the bigger ion thing, right? That why is barium ion less exothermic? So you're going to write that barium ion has a lower charge density compared to calcium ion. Why does it have a lower charge density compared to calcium ion? Because it's a bigger ion. It's got a, as it has a larger ionic radius. So as it has a much larger ionic radius. And because of that, that would lead to hence less attraction for what? For water molecules. ठीक है, is that clear?
Yes, sir.
Yes.
Yes, sir.
ठीक है, just give me 1 second. That's a less attraction for water molecules. ठीक है, so we're done with that. That's now next one. So again, I think that's describe in terms of bond breaking and bond making what happens to the solid ionic lattice when an ionic compound dissolves. So basically, you just have to tell the whole process, which is you break the lattice, ठीक है? So the ionic lattice needs to be broken. That's the first thing. And gaseous ions are formed. Let's just about what happens after that. Then those gaseous ions get hydrated. So your gaseous ions get attracted to dipoles from water molecules. Dipoles of water molecules. And they get hydrated. और तो कुछ नहीं पूछा. What else is he asking? He's asking the same in terms what happens to the. That's it. ठीक है, that's it. Again, what is meant by the term enthalpy of solution? It could be endo exo. It's both. ठीक है, so it's the energy released or absorbed when 1 mole of substance is dissolved in water. That's it. ठीक है. So when you just dissolve 1 mole of substance measured under standard conditions. He's not talking about standard conditions, so we don't need to write that. That's the next one. This one. So in this question, he's saying you're supposed to figure out the enthalpy of hydration of Cl ions. So again, it's a similar question. The lattice energy is given, the enthalpy of solution is given, the hydration of magnesium ion is given. So I'm going to draw the Hess cycle, which is MgCl2 solid. And it turns into aqueous ions. So it becomes Mg2 plus aqueous. And it becomes 2Cl minus 1 aqueous. Okay? So that is your what? That's your enthalpy change of solution. Ab kya karna hai? You're going to break the lattice. So it's going to form gaseous ions and its Cl is going to form gaseous ions. And then you're going to hydrate them. Now the enthalpy of solution is given. That's what? Minus 55. So breaking the lattice, that's minus lattice energy. That's given. That's 2524. Plus 2524. Remember, we're going in the opposite direction. And then hydrating the ions. Magnesium is given. That's minus 1925. Cl is not given. So Cl, I'm going to take it as X. So it's going to become 2X. That's going to be the enthalpy of hydration of Cl ions because you got two Cl ions. So one path is equal to the other path. So minus 155 is equal to the rest of the thing, which is 2524. Plus 2X and minus 1925. To find out what X is. कि क्या आ रहा है?
Minus 377 आ रहा है.
अच्छा minus 3.
77.
ठीक है. So you're getting minus 377. Can somebody double check this? And are we getting the same value or not?
Yes, sir. Minus 377 ही है.
ठीक है.
I also got minus 377.
ठीक है. So everyone's getting minus 377. अच्छा, moving on to the next one. Okay, how do I move on? Just a second. The enthalpy change of hydration of Na plus 1 is minus 410. Suggest an explanation for why enthalpy of hydration of the Na plus 1 ions. It's the same question. Achha, but what's the answer to this one? Like, why is Mg2 plus more exothermic? But what's the explanation? It obviously has greater charge density, but why? But this is going to be more exothermic, right? लेकिन reason क्या होगी? Why does it have a greater charge density? Anyone? Ibrahim, क्या होगा?
Ionic radius.
No, the first thing is obviously it's got a greater charge. Okay, so that's
Greater
because
charge.
so one is it's obviously got a double charge, right? So it's greater charge. And second, that's going to be it's also smaller in size. Okay, remember Na plus 1 and Mg2 plus, they both have the same number of electrons, so they should have the same size. But Mg has 12 protons. So since it's got 12 protons, since it's got 12 protons, it's got a stronger attraction for its electrons. So which is why it's also going to have a smaller ionic radius. Okay, is this clear?
जी sir.
अच्छा, बाकी अब ये वो क्वेश्चन आ गया. ठीक है, this is the exact same question which we just did, and it's a 4-mark question over here. Describe and explain how the solubility of group 2 sulfates varies down the group. 4-mark. Okay, and that's your answer. We just wrote it down. Okay, I'm just going to. So why does the solubility of group 2 sulfates decreases down the group? So down the group, the cationic radius increases. Both delta H lattice energy and enthalpy of hydration, they both decrease. But the lattice energy decreases less compared to hydration. Hence, overall, your enthalpy of solution becomes more endothermic down the group. Is that clear?
Yes, sir.
अच्छा ये हो गया ठीक है. This is ये clear? Is this clear? This one? Everyone.
Yes, sir.
ठीक है. Remember, there's a standard answer, and you just have to give that standard answer. So the rest is why we're just going to do one more question. Write an equation for the reaction between lime water and CO2. So that's what's going to happen in this case. Lime water is what? Calcium hydroxide. And so can anyone tell me what's the product?
Calcium carbonate.
ठीक है. Calcium carbonate plus H2O भी ठीक है. You're going to get H2O as well. But think of carbon dioxide as carbonic acid. ठीक है. So it's going to form calcium carbonate plus H2O. Explain why a saturated solution of barium hydroxide can be used to test for carbon dioxide. The reason it could be used to test for carbon dioxide is that you're going to get barium carbonate, which is also insoluble like calcium carbonate. I mean, the reason calcium hydroxide was used to test for carbon dioxide was that the solution you would get a white precipitate of calcium carbonate. It will turn lime water milky, right? Because calcium carbonate was insoluble. With barium hydroxide, you're going to get the same exact stuff, and you're going to get barium carbonate in that case, and that is also insoluble. So you're again going to get a white precipitate. The next one is explain why a saturated solution of MgOH2 cannot be used to test for CO2. Can anyone explain that? Because that's going to
Dissolve.
huh?
Dissolve.
No, remember, it's going to do exactly the same thing. It's also a base. You are going to get MgCO3, right? Which is also insoluble. So that is also a white precipitate, right? So you're still going to get a white precipitate. But why cannot that be? Why can't you do that? A simple reason. It's simply that. What is the solubility of MgOH2? Is it soluble or insoluble? Is soluble or insoluble?
Insoluble.
It's insoluble. Okay.
Insoluble. So you already have a solid precipitate. Even if so basically nothing would happen. Even if the reaction doesn't happen, you had a precipitate initially, and you're going to get a precipitate anyways, right? Either way, whether precipitate forms or doesn't form, the solution already has a precipitate. So you won't see any change happening. Is that clear?
Yes, sir.
In the previous ones, barium hydroxide was very soluble, right? So you had an aqueous clear solution, and then all of a sudden you got a precipitate, right? Even calcium hydroxide was partially soluble. So you had kind of a clear solution, and then all of a sudden you got a strong precipitate formed. But the problem over here is that you already have a precipitate to begin with. So if a new precipitate forms, you wouldn't notice anything happening, right? TK, is this clear?
Yes, sir.
Yes.
बस ठीक है. So ठीक है, we're just going to do more past paper questions, ठीक है, next time. So we'll continue next time, and I'll share this workbook as well, ठीक है, with you guys.
Thank you, sir. Allah Hafiz.
Thank you, sir.
Allah Hafiz.
Sir, can you send the updated notes?
ठीक है. Are you on the did I add you on this thing, whatever this is?
I made
on
the
the
OneNote.
yeah. Can you
I
just
made my Microsoft account today, so I don't think you could have added me until today.
okay? Can you like just send me your email over here in Zoom?
Uh,
Just message me. I'm just going to do it right now.